Scale factor. So scale factor involves making things larger or smaller, but keeping the overall shape the same, just changing the size. When the scale factor is greater than 1, like for example, if we're doubling something, it's going to get larger. If the scale factor is less than 1, like between 0 and 1, let's say a half, then the object is going to get smaller. All right, so from figure 1 and figure 2 are right triangles. What scale factor was used to produce figure 2 from figure 1? So let's look at some lengths here, right? So for figure 1, we have the straight side, the vertical and horizontal sides are the easiest ones to measure because they're on the grid. So this has we could say a base of 3 and a height of 3, right? And this one, 1, 2, 3, 4, 5, and 5, right? So we know that it's getting larger. So we know that we're multiplying by a number greater than 1, right? But the question is, what are we multiplying by? So we could set up an equation, right? Our original length times what number would equal 5, right? That is a very simple one-step equation. So if you think back to when we solved equations, we know it's not doubling, right? Because if it was doubling, that would be 6. So it's more than 1 because it's getting bigger, or it got bigger, but it's less than 2 because 3 times 2 would give us 6. So we have to figure out what that number is in between. So in order to solve this, the x is being multiplied by 3, so we divide by 3. And that's how we leave our answer. X is equal to 5/3. Now you might also see this written as 5 to 3 because we can write fractions and ratios using those dots, or 5 to 3. That means 5 of the small ones would equal 3 of the big ones. All right? All right. So the ratio can be written like this, or like this. Okay, so we have a rectangular flag that's 60 centimeters by 96 centimeters. What are the dimensions of a scale drawing of the flag using the scale factor 1 to 6? Okay, so now remember what we talked about. 1 to 6 also means 1/6. This is a scale factor that is less than 1, so this is getting smaller. But when it comes to scale factors, we always multiply. So I've got my original dimension of 60 times 1/6. That's going to give me 60 over 6, which is 10. And then I've got my original dimension of 96 times 1/6. That's going to give me 96 over 6, which is, what is that? Why don't I remember what that is? 96 divided by 6, is 16. So the new dimensions would be 10 centimeters by 16 centimeters. And sometimes when you see dimensions written, they use an X, so it might look like this, 10 centimeters by 16 centimeters. It doesn't mean you're multiplying them, it just means that it's just a convention. It's just a way to write dimensions. Okay, so in this one we have a perimeter. Now, perimeter is still just length, right? So anytime you have length and you apply a scale factor, we're multiplying. So we have a perimeter of 48 that was created from a triangle that had a perimeter of 3 meters. And we have to figure out what scale factor was used. So basically, we started off with 3. We multiplied by a scale factor, and we got 48, right? So I'm using this for multiplication, right? 3x means 3 times x. So we started off with 3, we multiplied it by something, and then we got 48. So what did we multiply by? Well, let's solve the equation. Divide by 3, divide by 3, and we multiplied by 16. The scale factor is 16. All right, few more, couple more. No, few more. This picture is 5 inches wide and 7 inches long. A photographer enlarges it so it's 17.5 inches wide and 24.5 inches long. What scale factor was used to enlarge the picture? This looks more complicated, but it's the same as the last one, right? You don't have to use both numbers for width and length. You can just use the two numbers that you were given for width, or just use the two numbers you were given for length. They give you more information to make it seem more confusing. So I'm going to use the 5 inches wide and the 17.5 inches wide. So I know that I started out with 5 inches and then I multiplied by something to get 17.5 inches, right? So now I'm trying to figure out what was the scale factor? What did I multiply the original by to get the new enlarged picture, right? So solve the equation. Divide by 5, divide by 5. X is equal to, I don't know what that is. What is it? 3 and something. 17.5 divided by 5 is 3.5. So the scale factor was 3.5. Another way we could write the scale factor is as an improper fraction. We could write it as 7/2 or 7 halves, right? Because 3.5, we do 2 times 3 plus 1 is 7/2. All right. A toy company is building dollhouse furniture. Rectangular door of a dollhouse has a height of 7 centimeters and a width of 3 centimeters. What's the perimeter of the door on a scale drawing that uses a scale of 3 to 5? So remember, 3 to 5 can also be written as 3/5. So that tells me that we're getting smaller. Now, normally I would multiply the height by 3/5, the width by 3/5, and then find the perimeter. But multiplying 7 by 3/5, that's going to give me a bit of a mess. But actually, it'll be fine because they'll all have a common denominator and we can just add them all. All right, so I'm going to multiply the height of the door by 3/5, and I'm going to get 21/5. I'm going to multiply the width of the door, that's 3 times 3/5, and I'm going to get 9/5. Now, remember, perimeter of the door. That means I've got 2 of these, right? This is 9/5 here and 9/5 up here. And this is 21/5 here and this is 21/5 here. So now I've got to add all of it together, right? So what I'm going to do to add it together is I'm going to double this and get 42/5. And I'm going to double this one and get 18/5. And then I'll add them together. And 42 plus 18, so 42 plus 20 would be 62. Take 2 away, that would be 60/5, which is 12. So the perimeter of the door on the scale drawing will be 12 centimeters. Now, the other way you could have done this is to find the perimeter first and then multiply by the scale factor. So let me show you what that looks like. Find the perimeter first. Remember, I've got 2 heights and 2 widths, right? I've got 7 here, 7 here, 3 here, and 3 here. So 7 plus 7 is 14. 3 plus 3 is 6. That gives me a total perimeter of 20. Then I could do 20 times 3/5. And that would give me 60/5, which is 12. So a lot shorter. The reason why I didn't show you this method initially is because this only works if it's perimeter. If they're asking you to find area, then you have to multiply the dimensions first. Scale the dimensions first, and then find the area. Okay, it doesn't work. Like this method doesn't work for area. It only works for perimeter and length. All right. So the last one, we have an advertisement that's 144 inches wide and 42 inches long, and they're going to create a billboard from that using a scale factor of 4. So what are the new dimensions? Okay, so if my scale factor is 4, remember the scale factor is what we multiply by, right? So for my new width, I'm going to do 144 times 4. And for my new length, I'm going to do 42 times 4. So I'm just going to do that in my calculator. I'll pause it and resume. So my new width is 576 inches, and my new length is, oh, that's weird. The length is shorter than the width, but that's how it was given. My new length is 168 inches, right? I just took the original dimensions and multiplied by my scale factor of 4. Okay, so now it says, what's the area? Okay, well, it's a rectangle, right? So area is base times height, which is the same thing as length times width. So now I'm going to multiply these two. So I've got 576 times 168, and that is 96,768 square inches. Remember, when you're finding area, your units need to be squared because it's squares that we're counting. And when you're finding length, like width, length, perimeter, those are all measures of length, then it's just no little tube. It's just regular units like inches, feet, meters. As always, any questions, let me know. I'm here to help.